Hi, welcome to OpenBMC session. My name is Sai. I'm from Facebook. This is James.
My name's James Mihm. I'm with Intel.
So this session is mainly for the OpenBMC. So we present it as an open source version of system management firmware stack. So the agenda for this talk. So we'll go over like what problem are we trying to solve in the data center, especially the at-scale data center, and then look at like use cases for the system management at scale. Some of the primary or preliminary use cases followed by some advanced use cases, and we will look at implementation like OpenBMC as a community project. So what's the problem? Like today we have data centers remotely, like all over the place, and they are having like a lot of equipment, whether they are compute, storage, or network, lots of systems, and they're all running. We need to let them run like 24/7. It's not like morning to evening. Actually, it should be running always up and running. And we don't want to have too many people. We don't have too many people at data center to kind of service us. So if there is a problem, we don't have people to kind of go there, fix it for us. And especially at scale, I think any problem that happens is going to need a lot of people. So we want to kind of have automated services to kind of detect, monitor continuously, detect, and then remediate without needing any human intervention. So that's the goal that we are trying to solve. So how does it help actually? So what I mean by like managing the systems remotely. I'll give you some preliminary use cases actually, which has been there for a long time. It's not something new. So the first thing is like inventory information. So that means like you have systems in the data center. You want to know who is the manufacturer, what is the type of the system, what is the part number, serial number, etc. And it's easy for one system to kind of keep track of it, but these days the complex systems are being manufactured as a multiple subsystems. Like say a big system may have a multiple small cards or small mezzanine cards kind of thing, where you want to keep track of assets in a complex system separately. And it's the way it works is like when during part of assembly, they just take the system and then scan each and every part and then upload into the database. Like all the information is up to date in the database at that moment. But once the system is being in service for 3 years, there could be problems in one of the subsystem. Like there is a card misbehaving or failure. So the technician goes there and then replaces that card and puts a new one. During that process, the repair process, they again scan it, and then the data is updated in the database. So this works smoothly for most of the times actually, but sometimes when there is a person that forgot to kind of scan it, or like there is a network failure, that means that when they scan the system, it doesn't go into the database. So then the database and the actual systems are out of sync. So we would like to kind of have a way to dynamically audit. Like I should be able to kind of look at my data center right now and see what systems are they really existing in the system today. So for that we need some kind of facility. Power is one of the pretty expensive operational cost in the data center. So if we don't have a need for systems, we would like to shut it down. And sometimes when we need like the load is too much, we want to kind of power it up. So we should have a control for power on, power off, anytime we want actually. And also the modern CPUs, they can operate at particular ranges actually. It's not like at one particular wattage. It can happen like all the way from 10 watts to 100 watts. So you should be able to kind of, based on the load, you should be able to tune the CPU. So that facility is there. So that's power capping. So we would like to exercise that capability remotely. Then these systems, like the hardware is pretty stable these days. There is not much errors, but once in a while there is some error happens. And at scale, you can imagine like even the percentage of failure is so low, you may see a lot of failures in the number of failures that happen at any moment of time. So we want a ability to kind of continuously monitor the hardware and then find if any error is there, take remediation action. Like say if there is a temperature sensor is not proper, just spin up the fans. Or if there is some threshold is crossing, shut down the system and then log the failure, so that when a technician goes there, collect the logs, they identify the failure, at least understand what happened actually on the system, what component failed or why it failed. Is it a problem with the hardware, or is it some kind of environment problem in the data center itself. Another use case for remote system management is debug. So typically when an application fails, you can log into the system and then get the logs from the application or the OS, understand what happened actually. But in certain cases, for example, like kernel panics, and even if you try to SSH, it doesn't respond. You don't have a way to debug the application. The only clues you can get is like if you can get onto the console of the device, maybe you can get some information on that. But in some cases, if the console itself is not responding, then you want to kind of ability to kind of look at what happened before it failed. So it's better to have the console log or history for a previous 500 lines probably. So that way you can, even if system doesn't respond, you should be able to kind of go there, get the history, and then look at the previous logs and understand like why the system failed. And last but not least, this is another basic feature of system management. You have all this hardware which has a bunch of programmable components, whether they are CPLDs, BMCs, BIOS, or even voltage regulators. They're all programmable today. So how do you program them? Like if you want to upgrade the system remotely, you don't want to kind of go there and then program manually, but you want ability to kind of program it remotely from other offices actually. So how we used to do this? So far it's nothing new. It's been there for 20 years. We add this component called BMC, which is a small microcontroller that you add to the basic system that you want to manage. And it should be like overhead should be pretty less. It should not be costly. It should be an expensive solution, and also it should not take much power. And most importantly, it has to be independent. So it cannot use even the power rail that is used by the system that it is trying to manage. So that means it has to have some standby power. And also it should have its own memory, its own CPU, its own RAM, its own operating system. It's totally independent of the system that you are trying to manage. So in the previous slide, you can see that one BMC is managing one system, but there are certain OCP systems that we have, like 4 systems in one box. So it's like it looks like a single system, but it has 4 independent servers. And one BMC should be able to manage all 4 of them independently. And this was not new, as I said before. It has been there for 20 years. But what has happened in the recent technologies with the silicon, inexpensive silicon, is the BMCs have becoming more powerful. So back in the days, it used to be like a simple 8-bit microcontroller, like a Renesas H8 kind of thing. That used to be the BMC. And you have all the code that is running on that is pretty bare metal. Sometimes assembly, sometimes bare metal C code. And then in the last decade, actually, the BMCs became powerful, like 16-bit microcontrollers. Now we added like FreeRTOS or VxWorks as the operating system, and then we do much more better manageability. But now I think if we take the recent system on chips for BMCs, I'll show a couple of examples actually. So you can see the capability of this one. Like this is a speed which is pretty standard in the data center BMCs. So it has like a 800 megahertz ARM core. And let's take another look at like Pilot 4 series. It has a dual core A9 with 500 megahertz. One more, which is Nuvoton's. So it has a dual core A9 800 megahertz. So these specs, I think if you take a look at like a decade or 2 decades back, actually, my laptop even that doesn't run this kind of speed, this kind of specs actually. So it's pretty powerful BMC. So what we can do with these BMCs actually? So what kind of additional advanced features that we can run? So one of the thing is like OCP LCD Debug Card. So when we want to debug physically, being there before the system, so we have these debug cards, and then the first generation debug card has a simple LEDs, like just 2 digits. It can represent like what happened in the post. It just failed, for example. Maybe B4 is the post code that happens if there is a DIMM failure. So somebody who is looking at that code, they should be able to understand like what that code means actually. And then people either have to remember those bunch of codes, or they have to look at like some kind of manual to say this failure means this is the component that failed, and then let me replace it. But this is the new debug card that we contributed last year, I think, in 2017. So this has added functionality. So I will highlight one of the functionalities like LCD, the screen. So whenever there is a problem, it tries to kind of give more information to the user. How does it do it? So the debug card itself has a small microcontroller, and then it talks to BMC on the IPMI bus, like using IPMB as the protocol. So they exchange information. So once the debug card doesn't have any intelligence, so it just comes up and asks like, what kind of system are you running? And then BMC sends all the information about the system, and then have the lookup tables for all the GPIOs, and then what error codes it gets, etc. A lot of information. And at runtime, like the microcontroller can query like what kind of information that BMC has to display based on the user input. I'll give you some examples actually, so where it is useful. So on the left side, you can see the post code status. So instead of just giving like say what's the code today at that moment, it just gives you what that code means in the user readable string format, and also gives not just that particular code, but it gives you like what happened before. So sometimes the code itself doesn't mean anything unless you know like what happened the before code, or maybe 2 codes below that. On the right side, you can see GPIOs. So the BMC monitors a bunch of GPIOs, like critical GPIOs, like say proc hard. So we would like to know like say what are all GPIOs in critical state. So we just say it's high or low. So it'll be visible on the screen. This is another example. Like on the left side, you can see the critical sensors. So the sensors are like temperature sensors. So it just shows like say what is the sensor name and the sensor value at the current moment. And on the right side, you can see the system information, like what is the part number, serial number, BIOS version, BMC version, etc. So everything is available in a single, using a user interface like a buttons. They can know like what's happening on the current system, like all the errors, all the sensors, and then the information about the system. The second advanced feature I would like to bring is the at-scale debug. So this is the previous to at-scale debug. The way we used to debug is we go to the system and then say there is a problem happening, and then we try to reproduce on one system and then connect using a USB cable and the blue box ITP, and then connect it to laptop and then debug like what happened, get the information from the CPUs for debugging. So this proves useful only in the lab, for example, where you saw the problem, you can reproduce it. But what if it happens in the data center, and if it happens once in a while, randomly, based on the applications? And there is no way today. I think the one way is like take the system out and then try to reproduce it on the same system, but sometimes it's not easy to reproduce the same issue on the same system at all. So thanks to Intel, I think they have the at-scale debug introduced in this generation. So what it gives is like say it allows you to remotely debug. So using BMC as the translator. So BMC monitors the network, a port, gets these commands and translates them into the JTAG commands, sends it out, gets back the information. So this way, I think if there is a problem in the data center, like a subset of machines actually, we can enable this feature. And then anytime there is a problem happens, we can just connect to that machine and then get the information. The debug becomes so easier, especially at the at scale, as the name indicates. The last one is about OCP NIC card. So the NIC cards become so smart, and then they are pretty complex these days. And especially considering these kind of systems where there is multi-host. So there are 4 hosts sharing one NIC, as the topology shows here. So 4 instances of operating system and 4 servers, and then a BMC sharing a single NIC. So that NIC becomes so important. If you lose the network for that, I think we are going to lose like 4 servers at the same time. So it's very important to manage that NIC, from BMC. So how did the NIC evolved actually? So initially the NIC was about like 10 gig back in the days 2012, and then it uses I2C for a sideband for the BMC. It's pretty slow. And come to the next generation, we have up to 100 gig speed support, and also the NIC support NCSI. So that allows like BMC to be on the network and then use file transfer, etc. Industry-wise, there is a lot of good amount of adoption as you can see on the right side. A lot of companies, they support this form factor, and then they support this OCP NIC card. There are a bunch of from management point of view, you want to update the firmware, maybe you want to monitor the link status, or like monitor the temperatures. There are a bunch of good management use cases. I'm not going to go through each and every one, but it's important to say like it's managing the NIC is another very important aspect of BMC. But there is no need to invent protocols for how do you manage, what kind of specification should I give it to the OCP NIC vendor. So there is well established standards in the DMTF called PMCI, platform management, and it defines like at the physical level, transport level, and then the command level. So these are very well established standards, and then as long as the OCP NIC supports these models, we can easily manage, like it doesn't matter like what kind of OCP NIC card or which vendor makes it, as long as they comply to this standard. I think with that, we will look at like how OpenBMC project as a community project is helping us to kind of implement these use cases. James.
Okay, I'm just going to give a status update on where we're at with the project. I guess new faces here for me. How many of you have been following the OpenBMC project at all? Good. So I'll go there. So back in, I think it was 2015, when Facebook came out with their implementation for an OpenBMC project, I think in March. And almost 6 months later, IBM came out with theirs. So back in about 2016, we got the clearance to go ahead and do an OpenBMC project at Intel. And we started exploring both of these and evaluated both of them. And what one conflict we can see, of course, that there were two. And I mean, we had one choice, so we could have come out and done a third, which would not have been, that would have been more confusing. So we approached IBM and Facebook to come to some kind of agreement on which one we should go with, and settled on one, and approached the Linux Foundation to have it be our governing body for it. And we announced that earlier this year. So the 5 of us had several meetings before then and came up with some ground rules for the project, and continuing on with that today. So it's I mean, as everybody probably knows, it's a Linux distribution. It's an OpenBMC. It's open source. And I just talked about the Linux Foundation. One of the main goals for having an open source project like this that I see is having a common way of doing things across all the different platforms, different companies, different architectures and stuff. You don't have to have special utilities and software for every piece of hardware that you got in your system, your data center there. It's a big advantage for that. We have these community calls that I invite everybody to attend if you're interested in it. We have a weekly teleconference on Mondays. And also on Mondays we have the release planning. A lot of these started off as like being weekly or being weekly, held weekly. And due to everybody's workload, we want to get maximum participation, and some of them have been turning into bi-weekly. So the kind of community-driven meetings. The release planning meeting happens on Monday as well. The Redfish meeting, there was a Redfish working group that got kicked off, and they were holding meetings weekly as well, and those kind of have subsided now because they've made a lot of progress, and there wasn't as much conversations going on in the meeting, so they kind of dialed that one back. So it's as needed. We have a security work group that is meeting bi-weekly now, and right now we're in the process of trying to define our security design life cycle of how we're going to handle vulnerabilities when they're found, and disclosure and tracking all those bugs. And then there's a new one. It was a test group that just recently got started. And you can all the community details are available on the OpenBMC GitHub, and I provided a link there for it. This diagram, I drew this up to try to show the difference between like the traditional development model that most people would follow versus what the OpenBMC offers us. On the left-hand side there, you can see where if you're doing a BMC firmware stack, you're getting firmware drivers and components from all kinds of different sources and trying to manage all of that yourself. And all of these different companies are doing the same thing. We're just repeating all of the same noise, or I don't want to say noise, but efforts there. With OpenBMC, it allows everybody to have one single place where you can participate. The BMC hardware vendors, they can add code and get their features out there faster by contributing to this one project, and everybody will pick it up at the same time. If you're a third-party vendor, if you're doing a storage card, a network card, an accelerator card on the PCI space, you can develop that yourself, and you can use the OpenBMC project to help get your manageability out there and get it to the broadest range of people that would consume your products, rather than going to every company individually. And that benefits everybody, because some of the problems that we've always had is that we don't have the head count to take on all these different projects that are coming to us to add manageability in our BMCs, and we have to put that in our schedule, and it winds up being a couple quarters out farther than what they would want. So that we're already I'm seeing some improvement at Intel on this, where people that are coming to us for manageability, and I say, here's a toolkit. You got the expertise for that device. You can start adding the manageability for that yourself as an application, and start upstreaming it. Of course, one change that happens here is with the firmware, the manageability firmware developer or providers kind of changes their usage models a little bit, because now they'll have their proprietary stack that they'll want to offer to customers. If they want to get involved in the OpenBMC space, it changes it where they're going to have to add a little bit more value on their services that they're going to provide for people. One of the areas where they can do that is by taking a long-term, doing a branch that has a long-term support package with it for their customers, because the customers are not going to want to be working off of something that's changing consistently. So there'll be some usage models around that. This is the high-level architecture diagram of what it is. All the communications between all the different applications is through dbus, and it uses systemd for all of the startup. It's pretty simple stuff. I think most people would probably recognize everything. Down there at the hardware layer, there you have the BMC SoC. One point I think Cy mentioned on it was that the BMC, of course, it's 3 different components in one. That's one thing to keep in mind in there. It's the video controller, the ARM management controller, and the Super I/O chip in there with all the USB and video and network driver stuff. And I put in there the TPM and some kind of rooted trust, which is the hint to Cerberus or Titan or Intel's version of platform firmware resilience. We're using U-boot, of course, to start up, and the Intel implementations will have a secure boot implementation with signed images and signed firmware updates that'll be made available as well. This is the build process, kind of high-level diagram of it. The Linux kernel, so the distributions uses Yocto as the framework for building the distribution. So it'll go and pull all the pieces to build. The current Linux kernel that we're building from is 4.17.18, and pretty simple stuff there. If you want to get started, this is from the GitHub repo on the OpenBMC GitHub. Just going and getting your build environment set up, downloading it. These are just some simple instructions. so, yeah. And I mentioned that we had a release planning work group. This is kind of the timeline that we're trying to target for the first release that we're trying to do for February of next year. Right now, the code freeze, code 1, is upon us. These were like our major milestones that we're trying to hit, and we're trying to hold everybody accountable to. But we understand that everything's in this in flight already. So, like one of the things that we wanted to do was try to have design docs for everything up front. For a lot of the stuff, there are design docs out there on GitHub that describe the implementation. But then there's some that are lagging in that, but that we're going to take that on as like documentation debt that we'll have to get up to date later. But you can see that like our feature freeze here in the beginning of next year, that's where we'll expect everything to be done so that we can have validation started and have that completed by the 1st of February there for the release date. These are the release priorities that we have. Also out there on the release planning website is the link to the spreadsheet that we have for all the different companies identified, all of the different features that the goal was to identify 5 features that were your top priority to have in that first release. So this is kind of a summation of all the different companies' priorities. It's kind of, and hopefully we'll hit it all, but we'll see. And this is the backlog that we have for all the other features that we have that we need to get in there. So it's and then there's probably even more stuff that we could add onto that. One thing that's happening next week, so I don't know how many of you are on the mailing list, but there's a hackathon being held at Intel in Oregon. And I've been organizing it, been sending out notices on the mailing list and getting, right now we have 37 different members coming to the event, not including the Intel members. I think the Intel count is up to 22 now. So I have a max size limit to go for the room. There's still plenty of room, so if anybody's interested in going, there's still room to go. These are some of the topics that I'm hoping that we get to make progress on while we're there. And this is kind of community driven. I got input from people that were interested in the event and what they wanted to get out of it. So I tried to collect all of the topics that people want to talk about. This is the second hackathon event for the project. The first one was held at the beginning of this year at Google. And we're going to, kind of what's happening here in the beginning of it is that we'll have a discussion phase where we'll just have people be presenting on work that they're doing and trying to get ideas and feedback, and everybody can talk face to face and work out issues that that are being run into, and discussing requirements that everybody has, because everybody has a different take on some of the requirements, especially around security stuff. And these are some of the additional resources where you can get involved. Of course, the source code, the testing, Garrett used for code reviews. There's the mailing list, and there's IRC chat. And we have this web page that is needs some improvement on, but we don't have anybody to maintain that web page for us yet. So we're trying to figure that one out. And that's it. Well, the last slide here was one engagement, or I guess you can talk to this one better.
Sure, yeah. Yeah, so this is, am I on? Okay. Yeah, so how does this OpenBMC fit into the OCP ecosystem? So today when you look at like OCP ecosystem, like when somebody wants to contribute their designs, so they contribute, just take a look at like design collateral files. The files include like presentations, data sheets, specifications, schematics, design files, like even including the CAD files. But conspicuously, I think missing piece is like firmware. So nobody is contributing any firmware pieces into that. So we would like to change that coming up. So if you take a look at today's firmware, as I said like before, CPLDs, bridge ICs, BIOS, and VRs, etc. So some of these should be available as a binaries, or it could be, some people might say, my company has this source code, you should be able to build it. It's not yet open source, but you can build it. So you should be able to kind of deliver that. It should support that model. Or it could be like completely open source community projects like Core Boot or Linux Boot or OpenBMC. So people should be able to say, yeah, just go here, this is the make file, go there, build it, give this platform name, it should build, and then generate the binary for you. Or in some other extreme cases where, like say, OCP specific, so it is not available anywhere else, but OCP itself says this is a feature needed for like these platforms. So then that can happen within like OCP itself have a GitHub. The code can live in that. So there are multiple options actually. So but the idea is to kind of have a way for end users to kind of get access to the firmware first by some means. It doesn't prevent like a combination of these. Like for example, in case of BIOS or open system firmware, you may want to download something from Intel FSP, and then you want to use something from Core Boot project, then Linux Boot project. So you want to stitch them together. So the make file should allow that. So you should be able to kind of download all these individual binaries, binary blobs, and a source code from multiple open source projects, and then create a combined firmware for you. So that's the goal actually. So hopefully I think next year we should be able to kind of enforce this as part of hardware contributions. But that's where I think OpenBMC fits into this ecosystem. With that, I think I will open up for any questions.
Earlier, you have shown two examples of the BMC SoC.
Right.
We have to use it in order to support BMC.
Good question. So today I think the primary supported one was ASPEED, and Nuvoton is pretty actively working on it. So they are part of the ecosystem. So they contribute all the kernel patches. They're very actively contributing to that. So the idea is today we have one or two SoCs, but as the more SoCs come on to play, they should be able to kind of contribute their code and then make sure it is, the BMC is agnostic to the hardware.
Is there a process to validate or qualify additional SoC?
Today it is all happening ad hoc. Today it is happening ad hoc, means like say you come and then say support your platform, and then enable the features and then test it. Each feature has its own test cases. There's nothing like a validation test for like SoC. We are not there yet.
Yeah, one thing I want to add is that if for new silicon vendors coming on board, the first place that they need to start working on is getting their drivers upstreamed. Because that's one of the things that for the project, they did it once where they helped upstream some drivers to the Linux kernel. They're not in that business, and they have a hard rule that if you want your silicon done, you upstream it yourself. They'll gladly consume and help you get those applications going. But so
Yes.
So in your example of a single BMC serving multiple servers, how do you implement telemetry?
Telemetry means like
How
logs
do you
and
measure all the voltage, temperature, current, etc. from those server life?
each one has a sensor, right? So when you talk to BMC, you speak in sensors. Like each slot or each system has its own sensor. So then that way I think you can differentiate, like say which sensor is that for. Or for logs, for example, you have the logs for each one, a console, serial over LAN. Now instead of having one single serial over LAN, now you have 4 of them connecting to 4 individual servers. So everything like multiplies by 4.
Can you talk about the philosophy between host agent management and BMC management? You see a lot of the host agent functionality moving into the BMC over time, more along the lines of what the enterprise system guys do? Yes?
Yeah. There are, I think, certainly Google. I think they mentioned like they use a lot of host management. All their management happens through the in-band through the host.
Right.
But there are some systems, like say in Facebook, for example, we use out of band as management. So BMC is our entry point into like managing these systems. So it's like two ways.
Storage systems, I understand, the BMC is just controlling the box fans, right?
Correct.
Everything's done in-band for
That's-
storage system, right?
No, today, but I think even storage people, they are thinking about out of band management, like NVMe MI, for example.
Right, but that
So-
requires SMBus and MCTP support
Right.
in OpenBMC, which
OpenBMC.
is on your sometime in the future list, right?
True. That is
And
true.
part of it requires you to put MCTP support in Linux itself, right? That
Yeah.
hasn't happened.
So in band, I think definitely can manage, but there are situations where we are trying to make out of band as easy as possible, especially if it needs like hardware hooks into that place and protocols. We are working actively with vendors saying, okay, please provide this out of band also, not just in band.
There's a bunch of folks that would write the sort of NVMe MI pieces
Mm-hmm.
if they had that MCTP foundation to sit on, right? But they don't want to do all that kernel work and upstream work and all that other stuff, just to make the drives
Yeah.
accessible from the
So
BMC.
we are still in the transition phase for that actually. So the
Yeah.
MCTP work is there. I think Intel, definitely they have. Facebook has their own implementation, but within the community, I think that has taken a lower priority for today, for this next release. But definitely, I think MCTP will be the next one that people are addressing actually. So that way, once that is there, I think people can just keep on adding. MCTP we are adding even for the NIC management. So
Yes.
that way, I think it can be supporting both storage as well as the network.
Yeah, the MCTP management, that's a hot item even for numerous people, so it might get prioritized. Yeah.
Yeah.
Yeah, the one thing I wanted to mention on the release cycle, we're trying to do 2 releases a year, so we're trying to do a 6-month cadence for that. So,
Yes.
This whole BMC style of things is coming from the server area right now. What do you think about evolving this to the networking area? That is, you have your switch box and you have a BMC on this, having this
Yeah.
similar functions as of this remote update, which for up to now you were talking in-band to the box and while working on the same iOS or NOS or whatever it is
Yeah.
to update it. Would you imagine the same thing valid for your batch device, that you go outbound over BMC doing updates, doing the whole housekeeping stuff as well?
Good question. So I think I should give a history for this. The whole OpenBMC started with Wedge. So back in like 2015, all the BMCs were meant for server management. Storage systems, they use enclosure management, either a SAS expander, SAS controllers, or PCI controller vendors. They used to provide this enclosure management functionality. And switches never have the BMCs at all. They have this control plane and data plane. So control plane, the x86, there is a small process that manages the fans and other stuff. So when we did the Wedge as an out-of-box design or white box design, so we added BMC as part of that. So we wanted to separate like management plane from control plane and data plane. So now we have 3 planes in the switch. So we have BMC specifically for this purpose. So and then when we looked around, actually there is no open source implementation of BMC. When we talk to the BMC traditional ODMs, they say it takes 6 months to kind of build this BMC for your Wedge or switch box, because we don't know how to manage switches. So that's when we started like, let's start ourselves, from basics. Take the kernel, take the Acto, use the SDK from the vendor, build this OpenBMC from the scratch up. So to answer your question, I think the network is the one that started OpenBMC. So we manage all the Wedge 100, 6-pack, backpack, mini pack, all the systems that we see using OpenBMC. And going one more step ahead, actually, when we started doing the JBOF, like a bunch of flash, the Lightning and Bryce Canyon is our hard disk based storage solution. We added BMC into that. So we took that enclosure management functionality out of the controller itself, put it on the BMC. So BMC is the one that does the management functionality for that. As you said, pretty much everything is same. It's not just servers, but we need the same functionality in the switches and the storage systems. That's what we did. So
Do you have the impression the industry gets traction on this, so other people do as well?
Like Microsoft, for example, they opened up the Olympus that has a storage platform, and that uses OpenBMC. And on the switch side, like Wedge, the variations of Wedge. If you take a look at like OCP website, the Wedge has like about 50 different variations. Like different vendors, they put their own value-added services onto that. So now you can see like varieties of switches. All of them have the BMC in that, and they have the OpenBMC running. So yeah, to answer, I think all network, compute, storage, they all use BMCs.
One thing I want to add on to that, Sai mentioned that somebody quoted you like 6 months to do a special BMC for you. So one of the goals here with OpenBMC is it's a data-driven model. So if you're doing a cookie cutter kind of step and repeat operation for different servers for different things, that's a configuration change. You're not adding code unless there's a driver change or you're adding a new device and you have to add code. But it'll be a configuration change, and my goal would be for that be a, I'll say a 1 hour job. Just change the configuration tables, the topology, should be a configuration change. And the reason why I say that is because we've done that at Intel before. We had structured code where everything was table driven, and you're just changing platform information areas, describing how that hardware is, and I could do a platform port in about an hour. And that's the challenge to my team that's working on that.
Yes.
Are there any quantity mainboards that we can get in small quantities for experimenting with OpenBMC, or is
Yeah. So there is, I should put that link. Typically, I think the EVTs, I mean, the evaluation kits is what we use to kind of bring up this OpenBMC. Like ASPEED has their own evaluation board. But what is missing there is, like, say, we can all exercise all the BMC functionality, but there is no way we can exercise the host functionality. How do you talk to the host? So, and also it doesn't have all the security features, like verified boot kind of features, actually. So what we did was work with Portwell is one company who make these COM Express boards. So they have offered a commercial version of a kind of, we can say, a development board for OpenBMC. So it has it looks like a BMC board, but it has a COM Express where you can plug in any COM board onto that. So that way you have complete server in a kind of environment, actually, where you can test all the features. And we added TPM, dual SPI flash, so that we can verify all this verified boot for the BMCs, and TPM for the BIOS, and TPM for the host. So that's the closest I can think of at the moment. But I think that is some active discussion we are having to kind of say, how do we bring in like more people, like say, especially the students. When I go to the OSF, like Open Source Firmware Conference, there are a bunch of students actually who are showing very good interest in the embedded systems. They wanted to contribute, but they don't have a board, and they cannot go to the OCP, like OCP Marketplace. I think they have some offerings, but they sell it for more volume, actually. So I'm recommending like this company. I spoke to them again after I came back to say, can we offer it like more at price point where people can accept it, people can buy it, actually. So that's one product which looks like a server. It has a host plus BMC stuff, all the fans and everything else, actually. So
is Intel working on any of their reference boards to support OpenBMC?
Yeah, we're using a current shipping product as our development vehicle. Yeah. And one of our first targets is going to be a reference board. Whether, yeah. I don't want to get in trouble by saying too much about it. But, like for the, in fact, you can see it if you go to look at GitHub. You'll see an Intel meta file for the platform that we're using. Last word I had was that, like for the platform that it'll build on, S2600WF, it'll build and it'll partially function. I mean, we have it working internally when we're upstreaming all of our platform configurations, everything. And my goal is that by the end of this year, everything will be upstream, so anybody can build it for that platform and have it work. But of course, there's warranty issues that would apply because you would be replacing the firmware, and you would, can't return it to Intel.
The S2600 WF is also supported under Linux boot. So that's a nice, potentially a nice
Okay.
combination to get
Okay.
open firmware at both sides of the system.
That's good to know. I didn't know that. That's good. But yeah, no, we've had talks amongst ourselves about what do we do for just that question, because we want to enable people to go off and at a good price point. Because we looked at the Portwell too and went, it was cheaper to buy an Intel server off the market. And but anyway,
Yeah. And the last one on that was like Raptor. I think they do some Power 9 stuff. So they have OpenBMC base. So that is another opportunity.
anybody here planning on going to the hackathon next week? No? Okay.
Any other questions?
Okay. Yeah, if you have any questions, just
Yeah,
grab
I'll be
us.
here. Yeah.
and-
Thank you.